Welcome to this Oracle Database World on-demand session. I'm Mark Scardina, Director of Product Management for the Oracle Autonomous Health Framework. And today I have with me Shirasi Gosal, the lead developer for the Grid Infrastructure Management Repository, otherwise known as the GIMR for short. And we're going to present a new Oracle Database 21C feature that many of you have been asking and waiting for. And that is the ability to centralize the GIMR into its own cluster, letting it remotely serve your production databases and removing its local resource footprint. While this is a new 21C feature, there is so much demand that we are backporting this to 19C, which we will discuss at the end of this session. So to get started, Shirasi, can you give us a quick background on your time at Oracle?
Sure. Hi, my name is Shirasi Gosal. Primarily, I am a developer and I am working for Oracle Database Organization since 2014. And I was involved in the effort of grid infrastructure management repository development from the beginning. So that's all about me.
Well, I'm talking to the right person then. So for today's session, we're going to walk through some of the new features about the grid management repository. But first, we'd like to talk about some of the past pros and cons. So, Shirasi, what are the pros and cons for the GIMR?
Okay. Let's start with the pros first then. And Grid Infrastructure Management Repository mainly stores autonomous health matrices for real-time and post-mortem analysis. Actually, there are so many clients like Cluster Health Monitor, Cluster Health Advisor, DBQS Management, Clusterware Activity Logs. All these clients store their collected matrices in the GIMR database. And this DB provides default 72 hours of storage. As client loads are known, so the database is fine-tuned to minimize resource footprint in the prod cluster. And it has a built-in automatic lifecycle management, automatic HFLOS support, and as a result, no DBA management is required. So this is actually helps to get the health matrices analysis and all. Okay. And now if we are discussing about the cons, what happens that this database requires minimum 30 GB of shared disk space. As GIMR was part of the grid previously, the GI patching and upgrade integration required longer maintenance window because it required GIMR upgrade and patching as well. And another thing is that only remote centralized solution was provisioned for new member cluster greenfield installation only. So those are the cons we can summarize in its way.
Thank you. So we've had this grid infrastructure management repository for quite a while, and it seems to have gone back and forth. Is it actually mandatory or not?
Okay, so let me give the history here. Till 12.1, it was non-mandatory. From 12.2 to 19.1, it was actually mandatory. From 19.5 to ongoing 19 releases, mainly for the 19 releases, it is non-mandatory again. But in 21, it is recommended as a best practice. So we actually recommend it's a best practice for 21 onwards.
So even when it was optional, we were recommending that it's for best practice to install it?
Correct. We recommend it as best practice.
I see. So with this new 21 feature, are there anything different about this deployment option?
Yeah, actually it's little different from the earlier releases. And for the local GIMR, we have to install GIMR in a separate database home because previously it was part of the grid home. Now it is part of a separate database home. And this separated database home has to be dedicated for GMR. It should not be an user DB home. And we got feedback from our end user that monolithic upgrade and patching stalls GI upgrade and patching. But after home separation, this GI upgrade and patching can go through immediately without getting stalled for the GMR process. And in that case, user DB uptime would be small, and GMR patching and upgrade can take place separately. But one point to be mentioned here, that separate GMR home directory must be owned by the OInstall user, and it has to be a single rack-enabled instance with HFL over. So this is all about the local GMR deployment options. Now let's go to the new remote centralized GMR service, which is a new feature. Centralized infrastructure cluster for GMR service need to be created first, which hosts the PDB for the remote cluster. In fact, every remote cluster has their separate PDB in their centralized infrastructure cluster, and it's a dedicated installation option. Okay, and also it has some benefit of it, that it removes local GMR resource footprint in every cluster. And they have version backward and forward compatibility, which means that 21C remote cluster can have its own dedicated PDB at 19C centralized GMR cluster. So it has lots of benefit as well.
This sounds like quite an improvement and will address many of those cons that we talked about earlier. But
sure,
how do I actually install this new centralized GMR? Is there a new process?
Yeah, this is a little bit new. And in this case, some steps need to be followed. You have to install a new domain service cluster. Then you need to install a DSA local GMR in a separate Oracle database home. Okay, so unlike it was part of the GI before, it is now have a dedicated Oracle home for it. And to use the centralized GMR, after that, you need to create a client data file for your client cluster, and then you need to install that standalone cluster with remote GMR using the client data file generated in the previous step I mentioned.
That seems pretty simple.
Sure.
So you mentioned about this new infrastructure cluster. Any tips on performing this domain services cluster?
Sure. Yeah. Okay. So select your infrastructure servers and storage for the multi-nodes cluster. And here is no paid Oracle license is required to run these softwares. Perform a new cluster install, selecting the DSC option, means domain service cluster option, while running the OUI for the cluster installation. At the cluster configuration screen, please select the configure and Oracle domain services cluster. And when using ASM, ensure you create a separate disk group for the GMR, just like MGMT as a separate disk group. So please use a separate disk group.
So we can have only a single node for a cluster?
Yes, of course you can. But the best practice for HA to use multi-nodes cluster to use HA facility.
I see. So is there a specific DSC installer option in the Oracle installer?
Yeah. While running the OUI for cluster installation, at the cluster configuration screen, you have to select configure an Oracle domain services cluster option, and it will create the domain services for you.
So once I've done that, then you talked about having to install another database home. Is this new for 21C, and are there any special steps or tips?
Yeah, sure. Yeah, it is new actually. The database home in which GMR is configured is a standard RAG database software only installed with a few exceptions. Okay. So, and you do not need to create database. MGMDC command will do the creation of database and the deployment underneath. And the GMR DB and the DB home and GI homes must be under the same owner, just like Grado install. So they has to be under the same owner. The Gmer home must not be under the GI home. The Gmer home's Oracle base may be the same as the GI home Oracle base. And make sure that the Gmer disk group is created. And when you run the mgmtca create Gmer container, you please give the option for the Gmer disk group in order to create the Gmer. By this way, mgmtc command will do the creation of the Gmer database and the deployment under it.
Okay, that sounds pretty straightforward. So I don't need to worry about creating the database.
Correct.
Once that's all done, I'm ready to go to make use of the DSC, correct?
Sure. Yeah, you can do that.
Now that I've got my domain services cluster, you talked about having this client data file that I need to use for my client clusters. What is this file and how do I use it?
Okay, so this client data file supplies the DB credentials to the remote Gmer daemon client so that they can connect to corresponding PDB at the DSC. And this client data file is created on the DSC cluster by running create repos command from the Gmer home. The command is like that in mgmtc create repos client data file with the cluster name for the remote cluster. By the way, this file is an XML file. And once a file is created, you need to copy the file to the client cluster node running the GUI installer.
How is this used in the GUI installer? And is this any different than a normal cluster install?
Yes, when you are selecting for the standard cluster with remote Gmer, you have to pick up this credential file as part of the remote Gmer setup in create Gmer option string. There you have to browse and pick up this client data file so that installer can use it for the remote Gmer installation.
At the beginning of the presentation, we talked about having this backported to 19C because it sounds like such a desirable feature. Yeah. Now, if in 19C, it was an optional feature. Yes. So if I have a Gmer locally, can I just make that a remote Gmer and not lose anything?
Sure, you can do that. And there are some steps you need to follow to migrate an existing 19C cluster with local Gmer to remote. You need to set up one 21C or 19C DSC with the supporting version for the remote Gmer. And then you need to run mgmtc commands to move the local PDB to DSC, which will in turn generate client data file at the DSC. You need to copy that client data file to the remote cluster to import the credentials to connect to the corresponding PDB remotely. So by this way, we'll be converted from a local Gmer to a remote Gmer.
That sounds straightforward. Yeah. But now if I didn't select the local Gmer because I didn't want the footprint, but now since it's remote, can I actually add the Gmer as a remote Gmer to my 19 installation that never had one to begin with?
Of course, you can do that. Here, the steps are a little different. You need to set up a 21C or supporting 19C DSC version as well. And then you need to run mgmtc create repos commands with cluster name and GUID at the DSC centralized server, which will generate the client data file. And then you need to copy that client data file to your remote cluster and run mgmtc commands to import the client credentials at the remote cluster.
Well, this really sounds like a compelling feature in 21C and soon 19C. I believe you really have addressed all of the cons associated with the GMR. You've eliminated the shared disk space requirement on my local production cluster. We now no longer have any roadblocks to GI patching and upgrade because I don't have to upgrade the DSC because it can do forward and backward compatibility, right?
Yes.
And I don't actually need to install my new clusters anymore to make use of this function because I can use my existing clusters, if I understand correctly. So basically, we've addressed all of the cons.
Yeah.
And at the end of the day, our new centralized Jimmer actually allows us to get the full features and capability out of all of my autonomous health framework clients, correct?
Correct. Yeah, that's true.
Well, thank you very much. And
Thank you, Mark.
Hope everybody found that very interesting. For further information, we have an excellent install guide that covers this type of installation, as well as the Autonomous Health Framework User's Guide in our doc library. And I want to draw attention to a MOS note where you always get the latest Autonomous Health Framework for which the clients of the Jimmer live, and that is 2550798.1 for downloads from MOS. So I want to thank you for attending this session of Oracle Database World.